So amines are another functional group. Abhi tak you guys have done haloalkanes, haloarenes, like halogen as a functional group. Then you have alcohols, phenols, ethers, and then you had carbonyl related functional groups, carboxylic acids, aldehydes, ketones. This is the last organic chemistry chapter in your syllabus. Amines functional group. Do you guys know what is like structure of amines?
Ammonia, ma'am, NH3 derivatives.
There you go. Yes. So this is like the main primary amine group, and derivatives of ammonia basically come under amines. So ammonia is NH3. So derivative matlab each hydrogen substituted by an alkyl group. So that gives us different types of amines. If there's only one hydrogen substituted, so you get RNH2. This is a primary amine. Then if two of these are substituted, you get RNH R dash. Two alkyl groups, secondary amine. And when all of the hydrogens are substituted, you have R dash, R double dash. This is a tertiary amine. See, so these are like three different types of amines based on how many alkyl groups are bonded to the nitrogen atom. Just like with all the organic chemistry chapters, follows the same thing. We'll have a little bit of introduction, talk about the structure, nomenclature, and all of that, types, classification. And then we'll talk about the physical properties, chemical properties, and preparation methods. Okay. So when it comes to structure, like amines are defined by the nitrogen atom that is present. So what do you think is the hybridization of nitrogen atom? In this?
Isn't it sp3?
Yes. Even though there's only 3 bonds there, it is still sp3 because in each case you do have the lone pair of electrons on nitrogen. Okay, so sp3 hybridization. So according to this, what sort of geometry do these compounds have, at least at nitrogen?
Tetrahedral.
Tetrahedral, yes, that is correct. What is the bond angle? So tetrahedral usually is about 109.5 degrees. Would it be the same in the case of amines, or is it greater or lesser? And when I say bond angle, what about the angle between carbon versus nitrogen versus the other thing? It could be hydrogen in the case of primary or secondary amines. It could be an alkyl group in the case of secondary or tertiary. Let's call it E. So what is this bond angle? Greater than 109, less than 109? What is it?
Ma'am, is it less than?
Should be lesser because of the unshared pair of electrons.
Absolutely. It will be slightly less than 109.5 degrees. How much lesser, like the exact bond angle also depends on what is attached here, because you do have a little bit of steric hindrance there. But I think what I've read is it's approximately 108 degrees-ish because of the lone pair of electrons on nitrogen. Okay. These are your basics. Oh, another important point. Because of the lone pair of electrons on nitrogen, amines usually act as nucleophiles. Okay, so the lone pair of electrons, extra negative charge, are attracted to positive charge, so they're nucleophiles. Nucleophiles due to lone pair. Classification, you have primary, secondary, tertiary amines, depending on how many R groups are attached. Apart from that, there's another kind of classification. Then you look at what specific alkyl groups are attached. So the other kind of classification is just like with ethers. Here you have simple and mixed amines. So this holds or this applies only to secondary or tertiary amines. So simple amines, if all the R groups are same, and they are called mixed amines if it's mixed. It's a like you have different R groups.
So, Miss, for classifications, so amines are classified into primary, secondary, tertiary, and then the secondary and tertiary are divided into simple and mixed.
Yes. Yeah. Because primary में doesn't apply because there's only one R group attached. Usme to what are you going to compare? So if you have more than one alkyl group attached to nitrogen, then simple or mixed comes into picture. Because then you compare R and R dash. Agar ek hi hai, to simple. If all of them are different, then it would be mixed. That way. Okay, so then we look at nomenclature. Once you guys are done, I'll go to the next page and then do nomenclature. Let me know when you're done.
Done, ma'am.
Okay.
Done, ma'am.
Okay.
Done.
Shantanu is done. Okay. Ansh.
Done, ma'am.
Awesome. Nomenclature. How do you name amines? I'll take the simplest amine. So CH3 NH2. So NH2 hai matlab this is an amine. Abhi, so there's two. Let's look at two nomenclatures. If you have, like, if you want to do the common names, they are much simpler. So you just write down, what alkyl group is present, and then you end it with amine. So यहाँ पे methyl group is attached to NH2, so this will be methylamine. Similarly, you have ethylamine, butylamine, isopropylamine. And if you have multiple, like if it's a secondary, tertiary amine, you just list them all one by one, like ethyl methylamine, butyl ethylamine, that way. So it's just alkyl amine, and if there are multiple alkyl groups, it will be alkyl amine, that way. Now coming to IUPAC name, because there's like rules associated with this. IUPAC is also very, very simple in this case. Alkanes ka E hata do, so you get alkane, and then attach amine is the suffix for amine. So it's simple. So can you tell me what would be the IUPAC name for this CH3NH2?
Ma'am, haven't you already written methylamine?
That is not IUPAC name. That's a common name. IUPAC follows this format.
Methylamine.
Methanamine. So no E, it's just METHAN and then AMINE. All of it single word. Okay, we'll do one more. CH3, CH2, CH2, NH2. So what would be give me the common name and give me the IUPAC name for this. Send it over chat. Common name and IUPAC name. Mention whether you're sending the common name or the IUPAC name.
Ma'am, the first one is a common name and the second one is the IUPAC name.
Correct. Dhriti also got the common name. That is correct. Shantanu, Ansh, make it quick. So common के case में YL will be there. So this 3 carbon atoms है. So this will be propyl amine. Okay. So IUPAC क्या होगा? So Mitali and Dhriti guys got it. Ansh, Shantanu, send quickly. Ansh and Shantanu, are you guys sending? Hello. Are you there? Are you sending? क्या हो रहा है?
We to send now.
Yeah, you guys are right. Got your answers. Ansh and Shantanu, what is going on, guys? Why are you taking so much time?
Just a second.
Send it quickly. I've given the common name already. Send the IUPAC name. Right. In the meantime, Dhriti and Mitali, like, let me know in this case, how would you tackle it? Awesome. Okay. Shantanu, Ansh, got it. Propanamine, yes. Ansh has given a more accurate answer. Propane may there's 3 carbon atoms, right? So he's also given the position, which makes it even more accurate. So you can give that propan 1 amine. Nice. Good. Why do you guys take so much time? Sahi to hai answer. Okay, next let's tackle the case. What if we have more than 1 amino groups? Suppose I have like CH2, 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 and then I have a amine group here and an amine group here. In this case, how is the name going to change? IUPAC? So are you guys giving it a shot? Okay, Mitali has already sent. Yes. One tiny change. So instead of alkane, यहाँ पे E will be added. So this becomes propane, and then give the position of where the multiple amine groups are, 1 and 3, because they're on 2 ends. Fit diamine. Di represents that there are 2 of them. 1 and 3 gives you the position of where those 2 are. Okay. So only a minor change. Single amino group hai, so there is no, it's just alkane. If there's multiple amino groups, then the E comes back into the picture. Okay. What if it's a secondary or a tertiary amine? So let's say you have CH3, NH, C2H5. So common name is pretty simple. The format followed will be the same. It's going to be ethyl methyl amine. How are you going to do the IUPAC name for this? So if you're giving it a shot, sure. Otherwise, let me know. And single
Just a second.
And I don't get it. Single carbon atom, where what are you talking about? Good, Mitali got it. Dhriti, Shantanu, Ansh, you guys also giving it a shot, or should I discuss this?
Can you please discuss?
Yeah. Okay. So whenever you have multiple alkyl groups, again the IUPAC rules apply. First, see whatever is the longest carbon chain. So whether there are two alkyl groups or three alkyl groups, choose the longest chain. So in this case, यहाँ पे एक ही carbon atom है, यहाँ पे दो carbon atoms है. So this would be the longer chain. Longest chain will form the base. So alkanamine base जो है, that's going to be your longest chain ka thing. So it's going to be ethanamine. Again, just like with this thing, if there's more than two carbon atoms, put the position number of, ethan 1 amine, ethan 2 amine, like propane 3 amine, jo bhi hai. Propane 3 doesn't make sense, but yeah, propane 1, propane 2, like position number will come into the picture. Otherwise, straightforward, methanamine, ethanamine. Then extra methyl group jo hai, again, numbering applies only to the carbon chain. In this kind of a situation, like where they are attached to nitrogen atom, then the suffix becomes N. So nitrogen pe, there's a methyl attached. So this will be N-methyl ethanamine. Okay. So if it is a tertiary one, there's two of them. Like for example, if I have CH3, N, CH3, and let's say C2H5. So ethyl dimethylamine, common name will be the same thing. When it comes to IUPAC name, do you want to give it a try? Same rules apply, just that the prefix becomes N instead of the position number to indicate that it's attached to nitrogen atom. So again, longest chain C2H5 hoga. So it's ethanamine. Then nitrogen pe, there's two methyl group attached. So what would be the prefix?
2.
No. So two, like, how do you specify that there's two of the methyl groups or two of anything? Di, yes. So dimethyl, where is the dimethyl attached?
To the N.
Yes. So this will be NN dimethyl ethanol.
Pardon.
Okay. So that's how it is. Okay. Again, and then you have an aromatic version also. When you
Miss,
have,
1 second, can you go back?
yeah, yeah.
Yeah.
Okay. So when you have an aromatic benzene ring with NH2 substituted, so the simplest aromatic amine, this is called aniline. Okay, so this is the aromatic amine. Apart from this, you have something called toluidine, which is basically toluene ka derivative. So depending on where the CH3 is there, NH2. Suppose CH3 is over here. So this is meta-toluidine. TOU from tol. TOLU, toluidine. Okay, so toluene का derivative है. This is toluidine. IUPAC name, of course, benzene का derivative है. So IUPAC for this will be benzenamine. Same rules. So remove the last E and replace it with amine, benzenamine. This also will follow the same thing. IUPAC will be so amine is the main thing, then 1, 2. 1 second. Okay, sorry. So this particular thing, because it's a derivative of toluene, so this will be 3-amino toluene. Okay. Yeah, these are your aromatic ones. Yeah, let me know when you're done. Then we'll start with the preparation methods. Ready?
Yes, ma'am.
Okay. You guys look at the circular. It's announced that the board exam.
Ma'am, let's keep 5 minutes for talking about that circular.
Okay. End of
Because then we'll get carried away. Yes.
Okay. This is a small chapter, so I was hoping I'll finish off up to physical properties. Then tomorrow completely we can focus on chemical properties.
Okay, ma'am.
Okay, Mitali said ready, Thriti is ready. Ansh, Shantanu, where you guys at? Should we start preparation methods?
Yes, ma'am.
Okay. All right. So preparation methods, I would put them into 4 main categories. Okay. So the first set of reactions are all reduction. So you have reduction. So you are reducing all the nitrogen containing compounds by adding hydrogen to it. So you have nitro compounds, you have nitriles, that's cyanide, CN, and you have amides. Okay, so reducing all of these, remove oxygen, add hydrogen, you get amines. Then you have 3 very special reactions, like all of them are named reactions. So one is ammonolysis of alkyl halides. This is also very, very like logical. So you start with alkyl halides. If you do hydrolysis, like make it react with water or OH containing compounds, you end up getting alcohols. So instead, make it react with ammonia, you get NH2 gets substituted in that compound in place of the halide. So that's what ammonolysis is. You take ammonia and you break that compound. So you introduce NH2 in it. Then you have Hoffman bromamide degradation reaction. Hoffman bromide degradation, and you have Gabriel Thalamite synthesis. These are again very, you just know the reaction. There's also mechanism that I'm not sure if you guys have the mechanism or not. We can discuss if you want it. But again, these are like, you just need to know what are your reactant substrate, what reagent you need to use, and what is the product that you get. So beyond
Mom,
that,
we don't have any reaction mechanisms. Even in aldehydes wala chapter, we don't have a single one. Even in this one, we don't.
oh, you just need to know the reaction, like the
Yes, and like the steps, like like I think there are places where they're doing like acylation, and then like they're doing like a couple of things, just like what's happening there. Yeah.
Okay. Okay. All right. So we'll start off with reduction. This is very, very easy and very, very obvious. So reduction matlab you're introducing hydrogen to it. What are your sources of hydrogen again?
Hydrogen in the presence of nickel, palladium.
That is one. And another reagent you'll come across is LiAlH4, your hydrides. Okay. So first we're looking at nitro compounds. Nitro is pretty obvious, NO2. Go straight to the source, like H2 in the presence of nickel, palladium, platinum, Ni or Pd, and do it in the presence of ethanol. Then you get NH2 and H2O. Pretty this thing. Apart from this, just like with alcohols, you have a couple more other reagents also you can use. So one is H2 in the presence of like the catalyzed hydrogenation, nickel, palladium, platinum. Another reagent you can use is tin in the presence of HCl. And another reagent you can use is iron in the presence of HCl. Okay.
Mom, could you just go back for a second? I need to check something.
Sure.
Mom, you haven't included diazonium. That's because like it's deleted. Like I'm just like checking whether. Okay.
Yeah. Okay. Yeah. So these are your like hydrogen in the, like this is catalyzed hydrogen, or you can use tin in the presence of HCl or iron in the presence of HCl. Out of this is the most preferred reagent used, because when you hydrolyze FeCl2, you get your HCl back. So you can keep regenerating your HCl, like you can regenerate your raw material. So this is the most preferred methods used. Okay. So this, like only in the case of nitro compounds, this is the only reaction where LiAlH4 is not used. Okay. So that is nitro. Let's call it 1A. Next, reduction of nitriles. So again, same thing. Nitriles are C triple bond N. So again, reduce them with any, like just get hydrogen from somewhere, you get amine group. So both carbon and nitrogen are reduced. Like this is also a purely addition reaction where hydrogen is added on both ends. So you get RCH2 and H2. So the reagents in this case also, again, you can use H2 in the presence of nickel, like catalyzed by nickel. You can also produce, like use sodium amalgam. Amalgams are basically alloys with mercury. So sodium mercury amalgam with ethyl alcohol. Another reagent, again, as always, LiAlH4. So these are the reagents you can use for this. reducing agents. Okay. In this case, you can observe that you're basically like R, and then nitrile may you're converting this carbon into CH2. So you're getting like an extra carbon atom in the alkyl chain. So यहाँ पे R है, तो यहाँ पे basically you get R plus 1 NH2. So in this, like this sort of process is also called ascent of the amine series. Yeah, these are your main points. The main reaction is very, very simple. Like in all the cases, the same thing. You basically add hydrogen to whatever functional group you have. So you get amine. Only in the case of nitro group, you don't use LiLH4. Otherwise, pretty common. Hydrogen in the presence of metal catalyst. Otherwise, you have some specialized ones. Okay. Then you have reduction of amides. Amides, again, the same thing, nothing, no special notes about it. Amides are, you have your acid derivative. So you have C double bond O and NH2. So again, this you can use LiAlH4 in ether, and then you have to do hydrolysis. And you get R, CH2, NH2. So both the carbonyl group is reduced to CH2. So the NH2 is already there. So amide turns into an amine.
Ma'am, can we also like do a couple of example reactions right below the reaction? For example, we did reduction and of nitriles and amides. So like now can we take examples once we're done with all the reduction reaction?
Yeah, absolutely. Yes.
Yeah. Because in that flow, we might get like a hang of it.
Okay.
Because then in the end, it becomes like too much to do when it comes to reactions in organic.
Okay. Simple. We'll take, let's say, nitro group ही लेते हैं. Suppose simple CH3NO2, simplest nitromethane. H2 in the presence of nickel. So what amine would you get out of this?
Ma'am, methanamine.
Methanamine, same thing. So CH3 remains as it is, NO2 turns into NH2. So suppose I want to use LiAlH4 to get aniline. What is the raw material that I should take?
Ma'am, but didn't you write that LiAlH4 is not used?
So in which case will it work for me? Like what should I take in order to get? Hold on. Let's say this is my product. So what will be my raw material in order to get this?
Benzene ring, CH2, NO2.
Again, you just pointed it out that I can't use LiLH4 for nitro group, but I can use it in the case of nitriles and amides.
But ma'am, then won't it give you a different product, because then they'll become 2 carbon atoms?
No. So what should be my raw material so that I have CH?
Oh wait, see that C triple bond and will also do, right?
There you go. So in this case, this C will turn into my CH2 and this N will turn into NH2. That's why I corrected it. So that was the, like, I won't get an aniline directly. I'll get this compound if I use benzeneamide or like benzene nitrile. Okay, one more example. Suppose I use CH3, CH2, C triple bond N. This on reduction, anything, like let's say H2 in the presence of PT. What will be the product for this reduction? Like, give me the IUPAC name of this product. Okay, Mitali got it. Ansh, Dhriti, Shantanu, what would be the product for this?
Just a second, I'm typing.
Okay. Do you guys have regular school between your exams or holidays? Only like exams?
No, ma'am, we have holidays.
Oh, nice. So tomorrow we can start slightly early. We can do like 3 to 5 also.
Yes, ma'am. Or ma'am, if everybody is okay, you can take it in the morning as well, if it works out for everyone. And
I'm
for
cool.
you.
Oh, you have school, no holidays.
No, ma'am. She said I'm cool.
Oh, okay.
I think. Is it right?
Yeah, I said I'm cool. I'm fine with anything.
Okay. I have to see. I'll put it on the group if at all we do it in the morning. I have a Ansh, Shantanu, you guys sending your answer? Hello.
Ma'am, can you tell what it is?
So you tell me, no? So again, we're talking about reduction. So wherever you have double bond or a triple bond, hydrogen will get added to it. So start from LHS, like CH3, CH2 इसमें there is no change because all of them are single bonds. फिर क्या होगा? Like I have C triple bond N, what will that change into? या इसके बाद क्या आएगा शांतनु? And the rest of you send in your answer. Dhriti, I haven't received. So just check if you've sent it.
Okay.
Shantanu, I'm waiting.
Yes, ma'am. Yes.
So यहाँ पे क्या है अभी? Carbon is there, right? So there you go. Triti, yeah, I sent it to everyone basically. So this here,
Sorry.
yeah, H2, like hydrogens will get added to this carbon also, and hydrogens will get added to the nitrogen also. So this also becomes CH2, and then finally you have nitrogen that becomes NH2. Okay, so this is your final product. So propan 1-amine will be your IUPAC name. All right. One last example, we do one with amines. So CH3, CH2, C double bond O, NHCH3. This one treating with LiAlH4 in ether and on hydrolysis. What will be the product? Either send the structure itself directly, or you can send the IUPAC name. Either way, whichever is easier for you. Give me the product for this.
Ma'am, can I give you the IPSC name?
Yeah. Either
Huh.
or. Check the total number of. Okay, yeah, Mitali. Now we have
Yes, sorry.
Okay. Ansh, Triti, and Shantanu, you guys working it out?
Yes, ma'am, I'm typing the answer.
Okay. Ansh and Shantanu?
Yes, ma'am. This is so.
Okay. Ansh Gupta, haven't heard from you. Like previous one also haven't heard. You working it out? Dhriti, check carefully what is given here.
Sorry, ma'am, one second.
Okay, so Mitali and Dhriti have sent. Shantanu, you said you're working it out. Send on chat. You can either send the IUPAC name or the structure directly. Ansh, what about you? What's going on with you? Ansh, are you connected? Oh, not able to hear you. See if you want to like reconnect, disconnect and reconnect. Okay, yeah, got your answer. So a little change. This one stumped you. Shantanu and like initially Dhriti also made the same mistake. You guys got it that yeah, you have CH3, CH2. This will also turn into CH2. हाँ तब ठीक है. उसके बाद the rest of
There
it.
will be another H in the NH2 OX.
No,
Like
NH
there will be like a
this will remain as it is because it's completely saturated, no? So what all these reducing agents do is wherever there's like a double bond, triple bond, like they basically reduce that and then there's hydrogen added in that place. Okay, because if you see, that's what's been happening here. Nitrile hai, triple bond hai, hydrogen is being added, like something that's unsaturated. If there's double or triple bond, that's getting saturated. Same thing in the case of amides also. So NH2 is like right there, but this is getting reduced completely. So even if you would think CHOH hoga, again another hydrogen gets added, this becomes CH2 and that's lost as water. Okay. So even in that case, like the C double bond or carbonyl group jo hai, that turns into CH2. And यहाँ पे अगर NHCH3 है, so that remains as it is. The hydrogen doesn't affect this completely saturated thing. It doesn't break the bonds. Whatever double, triple bonds are there, it will substitute with hydrogen there. Think of it that way. Okay. Clear?
Clear, ma'am. Miss, 1 second.
Okay.
Yes, ma'am.
Right. We go to the next set of reactions, ammonolysis. Ammonolysis of alkyl halides. This is also fairly straightforward. Kind of new because we've always worked with hydrolysis. Abhi ho raha hai ammonolysis. So again, as the name states, like from that you get a hint that ammonia is the one that's attacking an alkyl halide. So RX. Okay. So this reaction is done at 373 Kelvin, high temperature in a sealed tube. So it is a nucleophilic attack. So ammonia being a nucleophile, I said this lone pair of electrons. Halides are electronegative in nature. So this is going to take the set of electrons and ammonia is going to attack the electropositive alkyl group that's there. So the intermediate that's formed is basically you have R. This is attached to NH3. Because it's donated the lone pair of electrons, nitrogen gets a positive charge. And because this took the pair of electrons, halide gets a negative charge. And this in turn is reduced or this is converted to amine, where like the HX is eliminated on elimination of HX. Also, there's another special thing about it is that if you don't monitor this particular reaction, the same reaction, like as long as there is ammonia, as long as there is the alkyl halide, it's going to keep on, attacking, like the lone pair of electrons on amines is going to act as whatever ammonia has acted as the nucleophile, and this is gonna keep continuing till all of the hydrogens are substituted. Okay, so you have a primary amine that's formed, RNH2. It's going to react with another molecule of Rx. Same thing's gonna happen. It's gonna take this particular alkyl group also, gets converted into a secondary amine, then reacts with another alkyl halide, turns into a tertiary amine. And again, this is going to undergo the same reaction and gets converted into a quaternary ammonium salt. So it's going to stop at this step because there's no hydrogen to get eliminated. So this is called a quaternary ammonium salt. Okay. So yeah, if you don't control this reaction, you are in danger of getting like a mixture of amines. That is the disadvantage with this. But otherwise, yeah, this is how the reaction proceeds. So you can see that ammonia, being a nucleophile, is attacking the alkyl halide, and it is substituting one of the hydrogens. So this is a nucleophilic substitution reaction. Okay. What other points can we talk about this? Yeah, so this R can be either an alkyl group or an aryl group. Like you can use this method to manufacture aniline as well. But as I said, like because of this is the disadvantage. Due to how all these steps are proceeding, you get a mixture of primary, secondary, tertiary amines. So if your focus is purity of the product, then this is like not exactly suitable. But if you just want to manufacture, if you want to get a bunch of amines, use this method. Yeah. And another thing, yeah, order of reactivity for halides in Rx. Order of reactivity, iodides are highly reactive because iodine is a good leaving group, followed by bromine, followed by chlorine. So getting the amine from the ammonium salt, you can do this by treating it with a base. So the base will kickstart this reaction and your byproducts will be, you get your like sodium halide salt and you lose water. So you're losing a hydrogen and a halide, but not exactly as a hydrogen halide. You treat it with a base, you get halide salt and water. So this is all about ammonolysis of alkyl halides. Simple, treat ammonia with alkyl halides. This acts as a nucleophile, ammonia as a nucleophile attacks the alkyl halide and forms this sort of like an ammonium salt. This on treating with a base, like you have a small elimination going on. So you lose a hydrogen and a halogen to give you your amine. Disadvantage is that this reaction can proceed with the amine that is formed. So you end up getting a mixture of primary, secondary, and tertiary amines, depending on how much you're controlling the reaction. Another point, because ammonia is acting as a nucleophile, this is a nucleophilic substitution reaction.
Done, ma'am.
Okay.
Done, ma'am.
Yeah, cool.
Done, ma'am.
All right. Ansh, proceed.
Yes, ma'am.
Okay. Next, we have 3 Gabriel Thalamite synthesis. Okay. So for this, Gabriel is the name of the scientist. Thalamide is a compound that is used in this synthesis. So let's start with this compound. This is the raw material, the substrate that is used to get your amide. Thalamide is a derivative of phthalic acid, which is a carboxylic acid. So phthalic acid, which is phthalic acid, looks like this. So it is a benzene ring with carboxylic acid groups present in the ortho position. So this is phthalic acid. Yeah. So your phenolphthalein, wherever you come across a PHTHAL kind of a thing, it's basically derived from phthalic acid. Like that. Okay. Now, thalamide is an amide that is derived from this acid. So thalamide looks like this. PHTHA, thalamide is an amide derived from phthalic acid. So structure, start off with phthalic acid ka structure, C double bond O. Then instead of OH, you have NH. So amide is basically C double bond O NH2, right? So this is an amide. So when you derive amide from phthalic acid, yeah, these two join in to get this structure. Okay, so this is the raw material used in this particular synthesis. So you take this thalamide, this is the main reaction. So take the thalamide, treat it with alcoholic KOH. Step 1, there is a water lost, water molecule lost, H and OH lost, and you get potassium thalamate, potassium thalamide. Same thing, except you have, N minus because you lose an H plus, you'll still have a negative charge, and K plus. Now this, on treating with an alkyl halide, you treat it with alkyl halide, you lose a salt like potassium halide salt, and the alkyl group gets substituted to this nitrogen. There you go. You have the start of this thing. Now you have your alkyl group, you have nitrogen, you just need to substitute what do you call, hydrogens on it. So the source for that you use is you do basic hydrolysis. So this step, either you can do acidic hydrolysis or basic hydrolysis, or you can use hydrazine. It doesn't matter. Basically, you need to give like a source of hydrogen. Think of it as an ionic source of hydrogen, because you need to get rid of this whole phthalic acid part also. So on doing hydrolysis, you end up with RNH2, and your byproduct is your phthalate salt. So this is again like a special important thing, because you are regenerating your phthalic acid by the end of the reaction. So once you have your phthalate salt, iska hydrolysis karne pe you get the COH back, and you can convert this again into an amide and then take it through this entire process again. So the key point is, depending on what amine you want, you have to use the correct alkyl halide over here. So this is what is going to give you the alkyl group of your final amine. Okay. So Gabriel Thalamite synthesis may, Thalamite basically acts as a reagent in this. This is not your source of the amine. And again, it's a synthesis. It's something that we study about it. It's a special process because it's efficient. Like you regenerate your phthalic acid back, which you can again convert it into an amide and then get the amine out of it. So here again, this I have star marked because in this case, you basically need to do hydrolysis. What you do hydrolysis with doesn't matter. Either you can do basic hydrolysis by using NaOH, or you can use acidic hydrolysis, or you can use hydrazine also. Okay. So to summarize, takes place in 3 steps. Step 1, basically this particular step is deprotonation. Step 2, so this step is substitution. All right, Ritya, come back soon. And step 3, the step is hydrolysis. So if you're done noting down, I'll put the 3 steps again, like for clarity. I'll rewrite this properly.
Yes, ma'am, I'm done.
Okay. Ansh and Shantanu, what about you guys? And highlight this so that you have that clarity that your final amine, what amine you get, depends on what alkyl halide you take in this second step substitution process. So if you have questions based on that, like you can, yeah. So considering this process, because because you're using a thalamide, it's not relying on the primary amine. The amine that you use, this is used to produce primary amines mainly. For primary amines. Ansh and Shanti, you guys done?
Yes.
Okay. So takes place in 3 steps. Step 1, you have deprotonation. So deprotonation occurs in the thalamite. So you have the thalamite. So this particular hydrogen is lost, minus H plus. So you get the thalamide ka anion. So if I use KOH, यहाँ पे K plus होगा. That is the thing. Then step 2 is substitution. So substitution. So alkyl halide से substitution हो रहा है. So whatever alkyl aryl group you introduce from this RH, that is what is being substituted over here in place of this thing. So you have the anion. on introducing Rx, you get this. NR. So you're one step closer to your amine, you have your alkyl group and you have your nitrogen. Then third step is hydrolysis, which is what is introducing your hydrogen. So this particular hydrolysis can be either acidic hydrolysis. So it can be done with either hydrazine, which is NH2, or acidic hydrolysis, or it could be a basic hydrolysis. So anyone. Okay. So these are like the main points you need to know about Gabriel Thalamite synthesis. Oh, so this was number 3, right? So we are on the last one, last preparation method. Okay, just let me know when you're done noting, like when you're ready for the next one. Then we'll discuss Hoffman bromamide degradation. And start in the next page. Let me know when you're done.
Done, ma'am.
Okay.
Yes, ma'am.
Okay. Dhriti and Ansh, let me know when you guys are also done.
Done, ma'am.
Okay. Ansh? Ansh Gupta?
Yes, ma'am.
Okay. So last one, Hoffman bromamide. Bromamide. Again, your raw material or your key reagent is there in the name itself. You're using a bromamide degradation reaction. So this is the template like thing with initial reaction. You're using bromamide. So it's a combination of an amide plus bromine degradation. So you do basic hydrolysis like NaOH. You can take it either alcoholic or aqueous. Basically, you need the presence of a base. Your products are going to be RNH2. So degrade hua hai. We got rid of this carbonyl group. And your byproducts are, so the combination of the carbonyl group with NaOH gives you sodium carbonate and the sodium salt, like this bromide will take, like this is a byproduct, and water. Yeah, so these are your byproducts. And yeah, this is like your main template reaction. So again, Hoffman is the guy who worked on this, who fine-tuned this process. Bromamide, so using combination of bromine plus an amide, degradation reaction. So during this process, in this reaction, original amide mein jitne bhi carbon atoms hai, you're losing one carbon atom from the chain. So that's like a degradation that's happening. Ascent was reduction of like nitriles. Hoffman bromamide mein degradation ho raha hai. You're losing one carbon atom in the chain. Okay. Key points about this, like during this process, like in the mechanism, what happens is the alkyl group migrates from carbonyl to nitrogen. So that's how you're getting the amine. So इसका migration हो रहा है. So this migrates from the CO to the NH2. And yeah, degradation, as I said, the final amine contains one less carbon. And the amide you started off with. Okay. So I have like an in-depth mechanism for this whole equation. Do you want to go over it? Or this is sufficient?
Ma'am, this is okay, I think.
Okay.
I think you can just explain it like verbally and not write it. Just like we can get more clarity. That's it.
Okay. So it's a really long process. So first the base attacks this particular nitrogen. So in fact, during the reaction, what happens is it's not like this bond breaks and then directly gets itself attached to nitrogen. First, the base, like the OH minus, attacks the NH2 of the amide, takes away the H plus and all. That makes it like during this process, from an amine group, this gets converted into a bromamide intermediate. So you get something like R C double bond O NHBr. SI group ban jayega. So then what happens is you make this complex very, very unstable, that ispe delta like there's a delta positive charge on this, and there's like a lone pair of like there's two lone pairs of electrons on this. So that's when this bond breaks and attaches itself, because this nitrogen gets really unstable, that it basically breaks a bond. It's like this breaks, alkyl group breaks a bond with the carbonyl and then migrates here. So that's this main thing. So during the process, you're making this whole part very unstable by introducing bromine also into the mixture, that this ends up migrating over here. And that's where, like then C double bond O is let go of. Again, the base comes into picture. And then there's a whole lot of things that happens, and then final hydrolysis ke baad you end up with an amine. It's a very, very long mechanism. But the main thing is during the process, the combination of bromine plus NaOH ends up, there's a bromamide being formed, which is CONHBr. Uske baad, that makes it really unstable, that the alkyl group migrates from the C double bond O to the NH2. So that's like your start of the amine being formed. Uske baad, there's like 2-3 rounds of hydrolysis where C double bond O is gotten rid of, and then hydrogen is introduced back again, and then you finally end up with your amine. Okay. This is the main thing. So it's 5:22, right? What we can do is we can do some questions based on preparation methods and then start properties from tomorrow. What do you guys say?
Yes, ma'am.
Okay.
Ma'am, but properties, there aren't a lot of it, right? We can finish physical properties.
Physical, yes, absolutely. Let's do that. Yeah, then we can keep the reactions exclusively for tomorrow.
Yes, ma'am.
So physical properties, again, will go by sight, smell, taste, then solubility and boiling points. Same pattern as always. Okay. First, sight. amines are colorless. Like pure amines are colorless, but if they're impure, so if you just leave it out in the air, they get like a slight yellowish, brownish kind of color. So pure amines should be colorless. But if you leave it out for atmospheric oxidation, like leave it out in the air, so air, carbon dioxide, like gases in the atmosphere oxidize it. So atmospheric oxidation की वजह से they get some color. Okay. Next, smell. So amines are not odorless. They have, so like basically the smaller amines, the lower aliphatic amines are, again, like just like what we saw with aldehydes, the lower ones are the ones that are more volatile and they end up having like a slight pungent smell. They have a very ammonia type of smell. Have you guys smelled ammonia by any chance?
Yeah,
Yes,
the
ma'am.
nose burns when you smell amine.
Yes, it does. The lower aliphatic amines have, so they are all gases with ammonia like smell. The higher ones are basically because they have high boiling point, melting points, they end up being like liquid solids. They're not as volatile, so you won't be able to smell them. The sweet spot, like you have specifically primary amines with greater than 3 carbon atoms. So they are liquids and they tend to have fishy smell apparently. And higher amines like your secondary, tertiary, if you have like 7-8 carbon atom long amines, they don't have any smell. Note again, like you guys mentioned that your it burns the inside of your nose, right? So the lower amines are extremely toxic. Which is like a good general rule to have in your life. Something smells, something burns, it's pretty, you can be pretty sure that it's toxic and you aren't supposed to be smelling it. Aromatic amines are also pretty toxic. Shouldn't be consuming them. Shouldn't be taking any amines actually in general. Then let's look at the solubility. Solubility is same pattern as what you'd find with alcohols and carboxylic acid and all that. So solubility decreases as the number of carbon atoms increases, as always, because hydrophobic end increases. So solubility like of the smaller amines is high because, again, just like with other soluble organic compounds, they form hydrogen bonding. Okay. So in general, like when I say solubility decreases, amines with greater than 6 carbon atoms are insoluble. Okay. And the hydrogen bond part is pretty important because that again affects the boiling point. The fourth point we talk about is boiling point. So amines may, again, we have like primary, secondary, tertiary, right? So between primary, secondary, tertiary, which ones do you think will have highest boiling point?
Ma'am, tertiary amines.
Why?
Because
Consider
no.
comparable molecular mass.
Hydrogen bonding. Oh, so then it'll be opposite, because like if the molecular mass is increasing, that means number of hydrogen atoms are decreasing, and H bonding will also decrease. So the other way around.
That is,
Primary amines will have the highest
yes.
boiling point.
So another way you can look at it is, so hydrogen bonding is one. Another factor is branching. Like suppose I have propanamine, my primary amine is going to look like this, but my tertiary amine is going to look like this. Basically increase the amount of branching, right? So that's one factor. And another factor is, as you said, primary amine has, like, there's NH2 over here, more scope for hydrogen bonding because there's more number of hydrogens attached to nitrogen. So both these factors come into picture. So primary amines, if I take a certain molecular mass, primary is always greater than secondary, greater than tertiary. So that one criteria I need to keep fixed. Otherwise, molecular mass, again, as molecular mass increases, boiling point increases. So that's going to disturb it a little. But if you have similar molecular masses, primary will have highest, tertiary will have lowest. So two reasons. One is extent of hydrogen bonding. Primary, it's higher. Secondary, as the number of hydrogen atoms gets lower, the extent also becomes lower. And the second reason is branching. Same as what you guys have been seeing in isomers, basically, any compound. More branching means less boiling point.
Ma'am, could you go back to Hoffman bromamide degradation?
Yeah.
Yes, ma'am. Thank you.
Yeah, these are all the physical properties. Chemical properties may, just to give you guys an overview, how many reactions do we have? So the main thing is basic character. Like we looked at acidic character in the case of phenol, in the case of carboxylic acids. For amines, we look at the basic character. Same thing. What affects the basicity? Why is the basicity there? And what all reactions are there related to basicity? All that. Then apart from that, we have alkylation, acylation, carbolamine reaction, and electrophilic substitution. So amines, there's an extra thing that you haven't found in the other organic compounds is identifying, like testing whether it's primary, secondary, tertiary amines. So these are all there. Yeah. All right. We have half hour. We'll do some questions based on this thing, because it's very information type, right? So we look at what sort of questions will be asked based on this. So once you are all done noting down, like once you're done with noting it down, then we'll start the questions. Just let me know when you're ready.
Yes, ma'am. Done.
Okay.
Yes, ma'am.
Shantanu is done.
Done, ma'am.
Done. Right. Ansh?
Done, ma'am.
Okay, excellent. Yeah, look at question number 7. I'm skipping the previous ones because they are very direct. Like you can look at your notes and get the answer directly. So I'm skipping them. Look at question number 7. This is also fairly direct, but it's talking about the side products of Hoffman bromamide. So just flip. Abhi, you guys have taken notes. Check your notes and tell me what are the side products you get.
NABR and H2O.
Just the two? NAB,
Oh, wait. C.
yeah. Okay. So C. So you get NABR, H2O, and Na2CO3. Yeah. All right. Next question. Send the option number on chat. Like I want answer from all 4 of you. Question number 8. Which of the following reagent is required for this conversion? So you're starting off with, so you have benzene ring CH2Cl, alkyl halide hai. You're converting that into a tertiary amine. So what will you use for this? Send the option number. Okay, Dhriti has already answered. Okay. So alkyl halide matlab this is a ammonolysis reaction. So check your notes. Ammonolysis ke liye, how would you convert it into an amine? What things would you need? Dhriti is the only one who sent the answer. Rest of you working it out. Okay, Mitali has also sent. Mitali, you're so close.
Ma'am, would you reshare your screen, please?
Yeah,
I'm so what?
you're close, but it is not exactly right.
Oh, okay. Just a second.
So there's 2 methyl groups attached to ammonia. So think of it in those terms. Nice. Triti, Mitali, and yes, you guys got it. Shantanu?
Ma'am, which question are we doing?
8. Where were you till now? So Cl ko nikal ke N and CH3 we need to introduce. Like there's 2 methyl groups attached to the nitrogen here. So think of what all would we need for that? In the meantime, rest of you, give me the answer for, these are all pretty direct nomenclature ke basis pe. Okay. Question number 21. So Shantanu, start with question number 21. Right, the main product of the following reaction. So what amine would you get from this? So you can see that C double bond O NH2 matlab we're using an amide and treating it with bromine and NaOH. So just you can either give me the Iupac name or you can write the structure like CH3 blah blah blah.
Ma'am, do we give you all the products?
The main product only. Don't need the side product. Side product though, एक ही same as what you answered पहले. So give me the main product for this equation. That's it. Good, Mitali already got it. That is correct. So have an amide and bromine, मतलब कौन सा reaction होगा? So based on that, check the template, like the reaction that you noted down, and then figure out the product from that. Dhriti also got it. Very good. Ansh got it. Good stuff. Shantanu? Can you figure out what reaction it is? Like preparation may given 4 reactions, na? So charo mein se which one is it? We figured out. Shantanu? Work on it. In the meantime, rest of you look at question number 27. So you can start doing this. Give the structures of A, B, C. So these are the main kind of questions you'll be getting. Like it's a mix of all the organic chapters that you guys have studied abhi tak. So we are starting off with alkyl halide.
I'm sorry, which question? Because like,
Ha,
there's a lot of
21.
back.
No? Give me 27. Do 27.
Okay.
Shantanu got it. Very good. So all of you look at 27 now. This was Hoffman bromamide. So bromine and amide. To C double bond over हट जाएगा, you just get CH2 and H2. Sorry, CH3 and H2. All right, now 27. First step, are you guys working it out or do you need a hint?
Yes, ma'am, working it out.
Working it out.
Okay, do that. Dhriti and Aman have, Ansh have gotten it. Sorry, brain is not. Nice. Correct. Mitali, see, final step mein, you're treating it with bromine plus NaOH. So
Ma'am,
how?
but it's asking A, B, and C, right? So we'll give you all 3, right?
Oh, okay, okay. A, B, C. ठीक है.
Oh, so wait, because like that's what it says, right? So I thought I'd
Yeah,
give
that's
you all
fine.
of them.
That's fine. That's fine. Yes.
Then is it right?
Yeah, A is correct. Yeah.
Ma'am, on hydrolysis of nitrile, what do you get?
Hydrolysis of nitrile, you get an amide. So this was in
Okay.
carboxylic acids. Like check the reactions, like preparation of carboxylic acids. So you're doing a basic hydrolysis. OH minus है. It's also specifying partial hydrolysis. Acidic hota, so directly you would have gotten a carboxylic acid, but because you're doing a
So
partial,
ma'am,
it's
the CN becomes CONH2, right, on hydrolysis?
yes.
Okay.
So CH3
I don't know how to name it.
CN.
Huh.
So you can just give me the structure. CH.
Yeah, CH3 CONH2.
So Ansh, that's where you made a mistake for B. The CN part of it is the one that's modified. So the CH2 will remain intact. So the CN, like the carbon of the nitrile, turns into C double bond O, and the nitrogen in the nitrile becomes NH2. So CONH2 हो जाएगा. Okay, and
Ma'am,
bromide.
CH2, sorry.
So the bromamide may, the carbonyl is the one that's eliminated. So you get an amine and you get CH3, CH2, NH2 only. You get ethanamine. So Dhriti is the one who did it right every step. Ansh, beach may you missed out on the CH2 here, but the rest of it is fine. Mitali,
I'm sorry, I missed your CH2. Yeah. Yes, so it's ethanamine.
Yeah.
Okay, ma'am.
Okay. Shantanu, you need to be faster. Haven't got answer from you. Kya ho raha hai?
Yes, ma'am. Yes, sir.
Okay. So 28 is very similar. You have a bunch of reactions. This I'll skip, like you guys do it on your own. 29 is also very similar. You've given like the initial and the final product. You need to figure out what reagents you need to use. First one is direct. The second one is isko acid ko converted into an amide and then amide into amine. 30. Yeah. 30, like all of these are the same. So this will give you guys an idea of what sort of questions. It's not going to be purely direct questions of the preparation methods you learned, Abhi. It's going to be a mix of all of the reactions that you have studied, Abhi. So look at question number 32. Explain any one method which is used for preparing amine containing one carbon less than the reactant. So that's why those little trivia notes for every reaction, that's also pretty important. And that. Ammonolysis of bromamide. Yeah. Shantanu, yes, 27 answers. Okay. Give structure of different isomeric. This is okay, you guys can do it. It's more grunt work than applying your brain. Why is Fe preferred? That's a direct question. Name the reagent used. Okay, you want to do 35. So there's 3 reactions. You need to figure out the reagents. So give me the answer. Like just do A, B, C. A ke liye, here you're converting nitrile into amine. So kya reagent hoga?
Ma'am, all possible reagents or only one reagent will do?
Any reagent, any one reagent. So if you look at, okay, B is also So this is phthalic anhydride. This you're converting it into phthalic acid and
Miss,
amine.
there are so many reagents. Now, which should we write?
Anyone?
Okay.
The third one, you need to be a little careful because you're already given hydrogen gas here. So you just need to tell me what will come over here. Okay, Mitali Dhriti have given A. Haha, yes, Mitali 3 is easy. B is the one that's a little like that, that would stump you. So how are you introducing the nitrogen then? So your reagent should have nitrogen there. This is not NH2. This is phthalic anhydride. So phthalic acid, say you remove water and I got an anhydride wala compound. Mitali, yes, correct. So along with NaOH or KOH, along with the base, the twist in this is that instead of giving you directly like RNH2, they've given NH3 directly. So what should I use? So Mitali, it can't be ammonia because like ammonia is, are you going to get it back unchanged?
No, ma'am. So then we'll have to use like a RNH2 or something like that.
So thalamide K synthesis say, so this is like, this is 2-3, it's going to take 2-3 steps. So this you need to convert it into a amide. तो उसके लिए एक reagent चाहिएगा and then amide into your final product. तो उसके लिए दूसरा reagent चाहिए होगा. So for that, generally amine के लिए you use RX, right? But यहाँ पे R नहीं है. It is hydrogen only. So your other thing will just be HX. So then you get your ammonia.
So ma'am, what are the reagents?
So first step में amide में convert करने के लिए, how do you convert anhydride into amide? You do hydrolysis, just say you get your acid and then you treat it with ammonia, right? हाँ, hydrolysis like
Yes, ma'am.
yeah, H2O plus ammonia से amide आ जाएगा. And then Gabriel Thalamite synthesis में you take a base plus if you take alkyl halide, you get an amine. So instead, you need to take hydrogen halide. In that case, you're going to get your ammonia back. Sorry, show you hints. Yeah. Directly says refer to text. So yeah, so amine ke liye you take you get RX. Instead of R, you want all hydrogen, so you use HX in that case. Yeah, so these are the kind of questions you get based on the preparation. So it's a combination of stuff.